All right, friends and neighbors, welcome back to the next chapter in our CCNA quest. This is chapter 4, using the command line interface. Now, along the way, we'll talk about a bunch of things that are related to that, but off we go into the CLI. So in this video, of course, we'll do the "Did you know this already?" questions. We'll get into the command line interface, some of the, how do you connect to it, and what's the actual components along the way. We'll talk about a couple of the switch types, and really these are the Cisco families of switches and the actual making of the physical connection. So I've got a picture, I'll show you an actual cable, and then we'll do some demo stuff. We'll talk terminal emulators, and then modes of operation for when you're actually working with the CLI. Maybe a little bit about password security. This is covered in more depth later on. And then the web modes, right? Can you talk to a device via the web? And then working with the files themselves on the Cisco device. And again, for this video, it's mostly about Cisco switches. We'll talk routing later on. Okay, did you know this already? Now remember, if you're new to Cisco or you're new to CLI, these are going to be completely foreign to you, and that's okay. But here we go. In what modes can you give the show MAC address table command choose to? Well, the show MAC address command, and really the show command, is how we get a lot of information from a Cisco device, in this case switches. And some show commands are available in multiple places and some are available only in one. And the modes that we're talking about are the user and enable or privileged modes. So both of these will provide this particular command. Now, one of the distinctions between user mode and enable or privileged mode is that in one place you can look at stuff, and in the other one you can configure stuff or maybe break stuff. And so it doesn't make any sense to give the casual observer the ability to reload the device. And so you have to be in enable or privileged enable mode to do the reload command. What's the difference between Telnet and SSH? Well, when we start talking about secure shell, this is a way to encrypt a terminal session or really what we might say are telnet sessions. So telnet sessions, we shouldn't use those at all, except for demonstration purposes. The password is visible in plain text, the username is visible in plain text, and every keystroke is visible in plain text. SSH secures all of that by encrypting the entire thing. So you can't see the username, you can't see the password, and you can't see the data. What type of memory is used to store the configuration when the switch is up and working? Okay, so for this we have to realize that when we type in commands and we tell a switch or a router how to operate, it goes into volatile memory or RAM, random access memory. That also means that if you power off the switch, the configuration is gone. And so that's where it goes initially. So what command copies the configuration from RAM to NVRAM or non-volatile RAM? And that is the copy running config startup config. Now there were a couple of variations on this theme. Most of it is just syntax. But the order is that you're going to say, I'm going to copy this to this. So that's the order here, and startup config then lives in non-volatile RAM. Okay, a user is in line configuration mode. Which command will place the user in enable mode? So what we're getting to here is that there are a couple of layers or a couple of steps in our configuration or when we're working with the CLI. And exit is one of the options. Exit just moves you up one level, and I'll show you exactly what that means later on. But there are two ways to get you all the way out to just enable, and that is the end command or control Z. So it turns out that there are a lot of control plus a letter options that will get you around or allow you to navigate a little bit. Okay, managing Cisco switches. So there are generally in network management, there are lots and lots of ways that we manage things. You can have specialized software. You can browse to devices via the web. So Each one of the devices that we're going to talk about, you can enable an HTTP server, a telnet server, an SSH server, an HTTPS server. You can tell them to send data to a management system. So there's lots of ways to manage a device, but we almost always start out with the command line interface. So how do you get to the command line interface? Well, you might use a cable like this, right, to get to the command line interface. And that means it's a straight up connection to the switch. But you might also have given that switch an IP address, which means that you could ping it, which means that you might be able to telnet to it or SSH to it, in which case those three methods, right, the console connection, the serial connection, telnet, and SSH would all give you access to the CLI. And when you're doing that, you have exactly the same set of options, exactly the same commands. You can do all the same stuff. Now, what kind of switches are we talking about? This chapter is mostly about the Catalyst and Nexus, right? So when you see those commands pop up here in the CCNA study guides, those are the switches that we're mostly talking about. But there are generally three families that Cisco has: the Catalyst, Nexus, and Meraki. Each family has lots and lots of models. So we could talk about, well, I'll show you a couple of different models of the switches today, but 2960, 3560, or would be Catalyst, the 9000 series from Nexus, and so on. Most of the time when we talk about CCNA stuff, we are going to be talking about the Catalyst switches, although you'll see the XE iOS pop in there too, which is for Nexus, or it's the more advanced version of the iOS. Well, what do we know about switches? Well, switches have different numbers of ports or interfaces, and we distinguish ports or interfaces by their speed. So we've got 10, 100, 1000, right? 1000 being 1 gigabit per second. You got 10 gigabits per second in these lines of switches that we'll be talking about. And then we have to get used to the names of the ports or the interfaces. So anytime you see an E, that's a 10 megabit port. F0 anything, or F whatever, is going to be fast Ethernet. That's 100 megabits per second. G is going to be gigabits. There's a couple of ways to distinguish those kinds of ports. It depends on what kind of chassis you're looking at. And then, of course, there's the 10 gigabit interfaces as well. Now, what might you run into in terms of a switch or an OS? Now, I'm going to call it an operating system because they've had different names for them. So Cisco bought Crescendo Communications in 1993 and inherited what they called their Catalyst switches, and therefore the Catalyst operating system, or CatOS. If you have to work with one of these, I'm sorry. Later, Cisco upgraded to the Internetwork operating system, or iOS, and that's most of the time. That's where I've spent most of my time. On newer switches, though, we see the iOS XE. Now, the commands are largely the same, and for the CCNA, you can study either one. There were just some modifications to the operating system for performance and so on. So I'm going to go into Packet Tracer here real quick, and we'll put a couple of devices out here. Okay, so this is a 2960 switch, and this is a 3560. And if we open these up, and we'll zoom in a little bit on the chassis, we can see a couple things. One is that we've got all of these ports here. Now, in the Catalyst 2960 switch, these are all going to be fast Ethernet ports. But down here, I'm also going to point out the console port. We're going to need that later on to manage our switch. That's the serial connection. That's our console connection that we're going to use. Now, if I was going to go to, hey, look, the CLI real quick. And so this will be our first look at some of this stuff. So we have this greater than prompt. And we'll do these again, but I'll show a couple of examples. Now, there's our question mark that tells me what's available. One of the things that I can see is a show command, right? And then I can do a question mark again, and there's MAC address table. Now, depending on the chassis, the syntax might be a little bit different. And then I just tab. So as long as there's one way to complete something, you can hit the tab key and it'll auto-complete. And so this will be the MAC address table. So that was one of the do you know this already questions. Now there's nothing in this because there's nobody connected to the switch. If I go to enable, right, now I'm now in a different mode. And now I can start actually getting ready to configure the switch. So notice the prompt changed, and if I type exit, I go back up one level. Now enable, I did ENA, but if I tab that, there's the enable. Okay, but what we really wanted to see here is the physical interface for the switch. And we also want to do some of the names. So while I'm doing that, on the multi-layer, I couldn't remember which one I grabbed. And so on the multi-layer switch, you have to turn them on in Packet Tracer. So if I say, let's do a show, again, show is, SH is short for show. I could do show interface, and then I say question mark, what do I have? Well, if I do, I just happen to know some of the names, right? So here is a fast Ethernet interface, and then this tells me all about the port. Now, one sneaky way you can do this is you can do a show int, and if I see what's available to me, I might say status, right? Now, the fun part about this is that it tells me about everybody all at the same time, but it also shows me the names of all the ports. So this is just one way to do this, right? Now, if I go over to the multi-layer switch, we'll say no to this, but really what I wanted to do is take a look at the physical, right? And we can see it's a slightly different arrangement of the ports. Sometimes we'll see that we have modules here. Maybe we'll pull up the 3650. See, we got a little different look-see into the animal here. And this is the one that will tell me that you got to turn it on. So this is where I have to actually bring a module here and power it up. And so that'll power this up. Some of them have switches on them. But again, if I zoom in, I can see some differences in the ports, the structure. This is just a different type of switch, multi-layer switch. Now, as long as we did that, say no to this, and I can do the same command. Oh, for heaven's sakes. And we can see a couple of things here. One is that I've got a different way of numbering these. Another one is I have a different way of naming them. These are gig ports, and I have this third number here. So depending on how you've connected your switches together, these numbers not only indicate the chassis and the port number, but also maybe where they are in a collection of switches. So how about that CLI? Well, I just showed you a couple of things, but let's break down the actual connection itself. So the image above me here, you see that light blue cable. So that's a console cable. That console cable goes between the PC serial or COM port or USB port and then the switch console port. Okay. Now the switch console port is a serial interface. EIA 232 is the standard. If we're going from a PC COM port, we don't have to do any conversion except maybe for this connection right here. So this connection right here is going from the DB9, right? In this case, to an adapter of some kind. Now this might be going to a COM port, but in this case, it's going to a USB port. And so when we think about our connection, whether it's universal serial bus or a COM port, which is doing EIA 232, we have to realize that this is, among other things, not Ethernet. Okay, it is a serial communication like Ethernet, but a different standard. Now, if you're using the cable, it's short range. It's limited to, a couple of dozen feet. So the standard actually goes out, it has a top end of 115.2 kilobits per second, I think. We're going to use a fraction of that, but it also is short range. You can't run it like you can run Ethernet. And I don't know if you noticed, but these are also, right, they're flat cables, right? So there's no twisting to preserve the electromagnetic protection. There's nothing to protect our signal at all. If I wanted to manage remotely, I could give the switch an IP address, and then I could use SSH or Telnet to get into the box from across the network or even across the globe. If we want to manage securely, right, we would do secure shell. Telnet is the other option. Chapter 6, we'll talk about those in more detail. And then, of course, we have the terminal emulator software. Now, when I was using this, right, this handy thing in Packet Tracer says, oh, well, here's your terminal emulator tab. Very nice. Or the CLI tab. But this is giving me what I might get from a terminal emulator program. So the way that we used to talk on the command line to devices was with a terminal, right? We even had dumb terminals. So we need something that, well, emulates that sort of connection. Probably one of the most popular ones today is PuTTY. Now, it depends a little bit on your operating system. I use PuTTY all the time, but you can see here that PuTTY has the ability to do a couple of different kinds of connections. I could do SSH or Telnet or serial, in which case I tell it what COM port I'm going to use. Now, this could be one that's mapped to a USB port, or it could just be a straight up COM port. And then here's the speed. If you look to the side, right, you'll see that we've got the terminal emulator software settings. Now, 9600 bits per second, that's just the speed. That is how the data rate is going to be on the connection. But if we look at more detail here, we can see that there are some additional configurations. Okay. So without going too much into EIA 232, if you send a byte of information, 1 byte, and you don't know when you're going to get it, because when you're dealing with Telnet or SSH, you're sending keystrokes. And if I send 1 byte of information, and then I stop for a little bit, and then I send a byte of information, it might be good to know when I start and when I stop. So that's the start and stop bits. We already know about the data rate. Flow control these are special EIA 232C characters, and we can say that we can do none here for flow control. This is largely ignored, but if we do no flow control, parity bit is an error control bit. So you can do even or odd parity, where you count the number of ones and zeros and you decide whether or not you're going to add an extra bit to indicate what the parity was. So for example, if it was odd parity and I counted 5 ones in the transmission, I would put a 1, or I would do a 0 to make sure that it was odd. If I was doing even parity, I would have put a 1 there. But the Cisco CLI doesn't do parity bits. So these are our settings. This is what we mean by this on the terminal emulator connection. If you get the speed wrong, you won't actually be able to read the characters. Well, let's take a look at how we might actually talk to one of these switches with a PC. Now, previously, if you've been working with these, you might go to your connections. You might say, all right, I'm going to do a straight through copper connection, and I'm going to run that to fast Ethernet, and then I'm going to run it up here to one of my fast Ethernet ports. So I might do that. Now that's Ethernet, right? We said it twice, fast Ethernet interface to fast Ethernet port. But if we look at all of these other kinds of cabling, we can see that there are a number of different kinds of cable that we might use. So now the question is, oh my goodness, there's a light blue cable over here. So now if I go over here and I say, well, what if I was going to go to one of my serial ports? So I might take my console connection now and run this up here. Well, what would I talk to? I can't talk to a fast Ethernet, right? If I try, I get this. Oh my goodness, what did I just do there? That looks bad. So let's move this then, and let's put it in the right port. We're going to actually run this to our console port. Okay. So now we have clearly 2 connections to our switch. So now, if I was going to talk to the switch, now I realize a little bit more about how things are happening. Now if I go to my desktop applications, right, let's show you those, and I go to my terminal instead, I can see the same settings right here. And then I say okay, and now I'm connected to the same switch. So this is exactly what you get when you connect to the CLI. Let's put this over here. So if I do enable here, I can see that the same command has been repeated over here. So now we realize that whether we're in Packet Tracer or in real life, what we're using is a terminal emulation program to talk to the switch. And this is what you would do if you were sitting on your desktop or anything else. And that's how you would recreate it in Packet Tracer. Okay, a little CLI a la mode. Well, the first mode that we'll talk about is user exec, or just user. You can look around, but you can't break anything. And so the prompt is the greater than sign. So if I am looking at this here, and I exit one level, I can see the greater than sign right there, right? That is user exec, or just user mode. Now, when I'm going to go to privileged mode, or enable mode, I can now issue commands to the switch, and we do the pound sign. We'll get to the pound sign for that. So what I'm going to do is I'm going to use the enable command, just like this, or enable for short, or ENA for short, or I'll tab it out, right? And notice that the prompt changed, and here I have access to a different set of commands, right? So if we compare, look, it's gone a whole page, right? So if I compare this, if I exit again, and we'll do a question mark here, you can see the commands that are available, the things that are available are different. So this is where you're not supposed to be able to break very much. Now you can also put passwords everywhere. So I could put a password here on the enable. You can put a password just to log into the thing. You can do telnet passwords, SSH passwords. You can put passwords all over these. We're not going to do those today because it just takes time. It makes things a little more difficult for a demonstration. Now there is one other command that I will show you that you get to from enable or from privileged exec mode, and that is configuration. So configuration mode is where you're going to tell the switch actually how it's going to operate. Now the configure command is how we get there, and we're going to do a configuration from somewhere. And the way that we're going to do this is with the terminal. So there we go. So now I go config T, or configure terminal, or conf T, right? So a lot of these are short or can be shortened. So I can go conf T like that. And you'll see that the prompt changed again. And so this tells you where you are. All right, we'll come back to this. Now the book example uses the reload command. You definitely wouldn't want to do the reload command from user exec or just user mode, right? That is definitely changing the way the switch operates or changing what's going on with the switch. So that is one of those things that would be held for the privileged or enable mode. Now with regard to the web UI, as long as I'm here, I'm going to show you another command. Let's do a show run or show running config. This is what's loaded into RAM. And I'm going to spacebar down through this. Now I can give this particular switch an IP address. And if I gave it an IP address, then I could browse to it on the web. Okay, let's have a little bit of fun with the CLI. Now we've already done a bunch of these, but I'll go through them again because it's nice to have the examples in front of you whenever you want to. And so what I'll try to remember is the arrows and then the hostname, speed, and line. So we'll do that. All right, we'll go back to our console just for fun. And what we wanted to remember was the question mark. It's a good place to start always. So the question mark, right, you forgot the command, you forgot how to complete a command, and so the question mark shows you what's available. And so you saw me use the question mark right there. Here's tab expansion, right? If If I hit the tab key, it expands it out as long as it's the only way to complete it. And then I say, oh, wait, I forgot what's the argument to configure. Well, use the question mark again. And so I can go config T, config tur, and then hit it. And then, oh, what can I do next? Oh, it's just enter. Okay, so now I'm in the configuration. Now, you can see to get here, right? To get here, I started all the way at the user exec mode, or just user. And I type enable, there's one level. And I type configure terminal, there's another level. Now if I want to go to an interface, I can go to interface or just int, maybe F0/, and notice the prompt changed again. So now I'm several layers in. I could type exit and exit and exit to get me all the way out. Oh, what was I using here before? Oh, if I use some of my arrow keys, here's some history for me. So if I do config terminal, there's a history at every layer. So if I do, if I don't, let me say that again. If I don't log all the way out, right, there's a history at every layer. But I'm going to go to int F0/1, and now what's available here? Okay, so I see there's a whole bunch of different things available here, but now I want to be done. If I type end, that gets me all the way out to enable. So I didn't log all the way out, so now I have my history, but I can also do Control Z, and that gets me all the way out as well. So there's a couple of control commands that get me to where I want to be. So you can navigate around the, so here's the prompt. If I'm trying to figure out what my command is, and maybe we'll do this a little bit longer so it's really obvious. Figure terminal, right? If I do Control A, that jumps me all the way there. Control F moves me through, right? Now the arrow keys do the same thing. Control P and Control N, they move me through my history. I find it easier just to, a lot of times, just use the arrow keys, right? So, you know, you have the history right there. Well, I just remembered the host name command. If I have a whole bunch of switches, it's very handy to give them individual names. Now, a lot of times devices are named for where they're located or what their job is. So if I do the host name command, right, I'm just going to offer it some kind of keyword. For right now, why don't we just call this SW1, like that. And take a look at my prompt. It's now changed to SW1. It's very, very handy. I heard a story one time that on a CCIE exam, they changed the host name to boot and made it very difficult to, at least for a stressed out individual, to figure out what was going on. If I go into an interface, now interfaces auto configure their speed. But if I'm dealing with a legacy device or something like this, I might say, well, the speed that I want you to use is a particular value. Or if somebody had put in a 10, right, I might say, well, wait a minute, I want to auto negotiate things. Now, another way to troubleshoot this is I'm going to use the show command, and I'm going to use the show running command. And you go, well, why is this switch operating funny? Oh, somebody put that speed command right there on my fast Ethernet 01. I don't want it to do 10 megabits per second, so I'll go right back in and I'll go into that interface, right? And I will say speed auto, right? So this is just navigating around here. At the bottom of the show running config, you can see there's all this line stuff. These are things that you can configure as to how you're going to communicate with the switch. We're using line 0 or the terminal, but you can say things like, I want to enable particular transports like Telnet or SSH. We'll talk about that later in one of the other chapters. Now, I suppose I should mention global versus interface versus protocol. If I'm in config here, anything that I do right now is going to affect the switch as a whole. So we might consider that a global configuration parameter. But if I go into an interface, what I do here will affect this interface and this interface only. I can also do things like, oh, this is a switch. Let's do LLDP. So this is not specific to an interface, but this is specific to a particular protocol. So when we're dealing with the devices, we have to understand that there's several layers that we can navigate in and out of, and that there are things that will affect the switch as a whole, or things that will affect protocol or a part of the operation, or an interface maybe. Now we've done some of the show commands already, so I'm not going to go back through those. But I encourage you to use the show commands with just about everything. Now, usually the show commands are run at either the user exec or the privilege exec or enable modes. There are tricky ways that you can use them other places, but fool around, take a look at what you can see on a device. The one that I didn't introduce is the debug command. All right, so the debug command is sort of a live feed of what's going on. So when you put in debug commands, what's going to happen is that as the device is operating, it'll send you messages about or print out messages about what's happening. So if you're figuring out a routing protocol or a spanning tree topology or something of that sort, every time something happens, packets are transmitted, topology changes, things of that sort, debug messages can be spit out to the screen to help you understand what's happening and help you fix problems. The reason I say be a little careful is that you can turn on debugging and get it to a level where you can't interact with the devices anymore. So if I'm here at the switch terminal and I go here, I can see that I've got debugging options here. Now this particular version of the iOS is a little bit limited, but I could say, well, I want to debug, oh, I don't know, debug IP something. What am I allowed to see? ICMP transactions in this particular case. So if there was ICMP stuff happening, I could use that to tell me what's going on. And then the way to get out of this is on most iOS versions is the undebug, and you can say undebug everything, and that'll get me out of the debug messages. So handy thing to remember. Okay, configuration files. When we configure a switch or any other device, the commands are stored in a file which resides in RAM. Okay, that is the running config file. If you lose power, it's gone. Now this brings us to what kind of memory do we have? Well, if you think about a computer, what does the computer have? Well, it's got RAM or DRAM, dynamic RAM. A lot of times you have flash memory, read-only memory, right? The chips on the board that store the BIOS or the UEFI. And then non-volatile RAM in this case is where we're going to put stuff that remains after something is rebooted. All right, so RAM is where we will load the operating system. And then you've got various flavors of storage where we have the image. The iOS is stored in an image file. You can also store other things, versions of configuration files, and then of course our startup files. The main files that we want to remember right now are the running config and the startup config. That's the one that is going to be there when the switch reboots. And then you can navigate in the exact same way as you would on any other OS if you were on the command line. So if you opened up a command window in Windows, or if you're on Linux, you can navigate around with these. And then lastly, we can copy, we can write erase, we can reload and reboot. So let's take a quick look at that. So here we are in my switch again. This is the same console. If I do a dir command here, I can see that I've got this bin file here, this binary file, and this is in the directory of flash memory. If I do a show run, right, this is my running config, and I'm going to make a change here. Do the same change we did earlier. We'll just change that speed to 10. Now, let's say that I want this to stay. If I reboot this machine, I want the command to stay in there. And we'll just show you real quick that you can verify that you just did something, right? Oh, I didn't show you this. Here's one thing I didn't show you, right? You've got this more thing here. You can spacebar, you can go all the way to the end. You can just hit Q, and that'll get you out. All right, now the copy command is where I'm going to copy from what to what. Well, in this case, I'm going to copy what I just did in running config to the startup config. So I'm going to do a copy, run, start, and what this should do is copy my changes to non-volatile RAM so that the switch reads it on startup. This is also where I could change the name of the file. I can copy this to anything, but the default is the startup config. So it says, okay. So now if I do a show start, right, there it is right there. So theoretically, this would be in there. If I had not done that change and not done the copy, then this would not be in the startup config. Well, there we go. And then the reload command. Now, if I wanted to erase things, I would do a write erase, right? That's not what we want to do. But if we did the reload command, that's how you reboot a switch. And there is the change that I made even after a reboot. Well, the Chapter 5 look ahead, we're going to look a lot harder at the switches themselves, how they operate, a little bit about spanning trees, some switch operations, source address tables, things of that sort. Some good meaty stuff for our next chapter, because this is really getting to things that show how the network operates. So not just talking about Ethernet again. Well, this has been the Cisco CLI. I hope this video was helpful in your, learning how to navigate, get around. So we talked about the connection, the navigation, and the modes of operation. We did some basic commands and files and the memory. So hopefully you have a really good understanding of how those are stored, how you connect to the CLI, how to get around, and then some details about the memory that's available, and then all of those different files, right? Running config, startup config, and then the fact that you can rename things. Like and subscribe if we are learning, and may those packets always reach their destinations. We're in this together. This is CCNA certification. You can do this.